All right, we're going to talk about in 7.1b, we're going to be looking at some portions, sample portions, or sample distributions for proportions. And what we have is an example number 2, all right, is that we have pennies made prior to 1982 were made of 95% copper. Because of the copper content, these pennies are worth a bit more than a penny, about 1.3 cents more. Pennies are made after that are only 2.5% copper. Jenna reads online that 13.2% of the pennies in circulation are pre 1982 pennies. Okay, Jenna has a large container of pennies at home. She selects a random sample of 50 pennies from the container and finds that 11, all right, 11 of the pennies are copper pennies, all right, pre-1982 copper pennies. Does this provide convincing evidence in the container that the error is greater than that? Okay, so we want to find out right here of our population. So our population is going to be, in this case, not our mean, but we're going to talk about P. Okay, so this is a proportion. And our population is actually all right, um, pre-1982 copper pennies. All right, and that's what we have here. So our parameter, okay, is going to be our p-value. And we state that it's going to be 0.132, or what we have up here, 13.2%. And that's what we know. I'm going to change this, make it a little smaller. Okay, now our sample is, we're taking a sample of 50 pennies from our container. So 50 pennies from container. All right, from our container. And on here we have this. Now our statistic is going to be p hat, and what we found is 11 of those 50s, of those 50 pennies, are going to be more. So we have right here 50, and if you put that into your calculator, you realize that's going to equal roughly about 0.22. So it's a little bit higher. And so we're wondering, was that just by chance, or does this provide significant evidence that the proportion of pennies in the containers that are pre is greater than this amount right there? So we want to know if this p-value, so we make a hypothesis, all right, alternative hypothesis we would talk about is going to be greater than, all right, 0.132. Okay, well, in any case, does Jenna have convincing evidence of this, of pennies per pennies? Well, she may or may not, but in order to figure this out, we're going to have to do a little test, okay, a little test, because this could be done by chance. So if I had two explanations for evidence to describe number 2, well, the answer is she may, right? Yes, or she may not, all right? No. If it's no, then that was just done by chance, okay? So no, we'll just have some evidence. Oh, yeah, she does have evidence. Yes, yes, she does have it. She does have some evidence. Okay, she does have some evidence because she found that 22, when she pulled out 50 pennies, 11 of them were pre-made 1980 copper pennies, so that's going to be greater than 13.2. Now the question is, provide two explanations for this evidence. Well, first off, it could be done just by chance. Okay, just by chance that happened. Or two, that yeah, the proportion, the population, or the parameter proportion is wrong. Parameter proportion is incorrect. Okay, so those are the two things. So either it happened by chance or the parameter proportion is incorrect. So now let's look at here. We use technology to simulate 100 SRS of size N50 from a population of pennies in which 13.2% copper pennies. The dot plot shows p hat, the sample proportion of copper pennies for each of the 100 samples. So you can see the proportion of all those happening right there. Okay, and so there is one dot on the graph at 0.22. All right, so we're going to say that that is that one right there. Explain what this dot represents. Well, that dot represents, all right, the proportion of pennies pre 1982. All right, pre 82 um, selected out of 50. Um, 50. The portion of pennies pre-1980 selected out of 50. Look at that, out of 50. Um, with, or maybe I should say assuming the population of pennies pre, oops, can't probably even read my writing, pre 1982 is 3.2%. Okay, that's what we have. So that one right here is essentially a portion of the pre-made, let's say out of 50 pennies, 50, assuming the population of the pennies was 13.2%. Now, assuming that this of the pennies in circulation is a surprising or randomly selected 50 pennies, all right, right here, or greater, justifying answer. Well, let's see. Okay, they took 100 samples and we found that it's going to be 1, 2, 3, 4. So there is a 4 out of 100 chance of that actually occurring, okay? Because that is how many pennies that where it's going to be that or greater. And if you take that right there, that is a 4% chance of that occurring, all right? Okay, is it surprising? I'd probably say yes, it is surprising to randomly select, all right, 20 or more pennies out of 50 because probability is um, less than 5%. Okay, less than 5%. There's only 4%. And so it is surprising. So based on the previous answer, is there convincing evidence? We would say yes. There appears to be convincing evidence. To be convincing evidence that the proportion of pre-1982 pennies in circulation is greater than 13.2% because of that answer. So yeah, we have convincing evidence that the proportion of infinity is greater than. So we have convincing evidence of that. Not to say that it is, but there's convincing evidence. And so that is how we can use a sample distribution and portion right here, all right, or some simulations to identify uh, if there is actually reason to believe that the population is actually different than what is claimed. All right, well, I hope this helps you out on your homework problems, and yeah, good luck in all the rest of your problems.